Hello and welcome to Molecular Mindset Episode 1 with Jake. I'm your host, sponsored by Dr. Pepper. Just kidding, I wish though. Wouldn't that be cool? One of these days. So today we're going to be talking about subatomic particles. Okay, so let's back up a little bit before we get into that. We've all heard of an atom, right? And I know it's cliche, but it's the most fundamental building block of the universe. It makes up everything, blah, 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 whatever. You've heard that. But it is true, right? Atoms make up everything around us, right? The wall, the whiteboard, the computer, everything makes up everything. But now, just like anything else that has parts, right? So an analogy I like to use is a car engine. An engine is a unit, right? It's a thing that allows us to propel forward, right? But then within the engine, there are different parts. Now, I'm not a mechanic, but I'll do my best. There's spark plugs and there's cylinders that all work together simultaneously to propel you forward in your car, okay? And this is much like an atom. So an atom is the building block of matter, right, all around us. But then you may be wondering, well, what makes up atoms, right? These are what are called oh wow, this is a very wiggly, subatomic particles, okay? I learned how to flip it so you guys can actually read it. Subatomic particles, okay? So before we get into that intimidating word, right, let's break it down. So we have our prefix sub. Now, where have you maybe heard of sub? Well, first thing I think of is a submarine, right? So submarine, break the word down. Sub refers to below or under, okay? And then marine refers to like the water, right? So submarines go below or under water, right? Now, how can we connect that to subatomic particles? Well, subatomic, in this case, sub refers to the same thing, under or below, right? So sub, under or below, and then atomic referring to, let me write down under or below. Atomic refers to the atom, right? So these subatomic particles are under or below the atom. What it really means is these are the parts that make up the atom. We have the atom, but then what are the moving parts, just like an engine? We have the engine, but then what are the moving parts within the engine that work together to allow it to do what it does, right? Which is make you go forward or backwards, or like my girlfriend hit a curb. Don't want to talk about it. Still, it was like just yesterday. So, where was I? Okay, so subatomic refers to the parts that make up an atom, right? So let's break it down. I'll go slow. Put it on 2 times if you already know some of this, or if you're really cramming for that test tomorrow, you keep telling yourself you're not going to, and here we are. So we have 3 components that make up any given atom. This is any atom, whether it's hydrogen. Over here, I don't know if you can see my periodic table. I know I'm a nerd. I don't want to talk about it. Hydrogen, or all the way down to oganesson, whatever, however you say that, right? Number 1, all the way down to the biggest element, number 118. Now, these 3 components can include the proton. Okay, that's 1 of 3, proton. Now, some properties of the proton. We'll get into more properties later, but the basic properties right now is the proton is in, I don't know why I said is. It's in the nucleus, right? You may have heard of the nucleus before. We learned about that in biology, about freshman year. But you learn like the nucleus of a cell, right? It's kind of like the heart of the cell in simple terms, right? But in this case, the nucleus refers to the center of the atom, right? So if we draw a circle, let's say, it's kind of a bad diagram, but you know, bear with me. Right in the middle there is, okay, let's get our minds out of the gutters. That's awkward. But that is the nucleus, the center of the atom. And that's where we're going to find our protons, right in the middle, okay? Now, protons, I'm going to erase that. That is not a good diagram. Protons are in the middle, or the center, in the nucleus, right, in the center of the atom. And they have a +1 charge, okay? Keep it simple. +1, not +0.5, not +1.5, +1 charge, okay? And like I said, these are found in the nucleus, in the center. Let me write center. And keep in mind, when I say in the center, center of what? The atom, right? Remember, we're making up the atom. These are subatomic. They're below or under the atom. They make up the atom. Within the atom, it's in the nucleus, okay? You can remember positive proton. Then we have the neutron, okay? And the way you can remember this, just like positive proton, you can remember neutral neutron. And this is also in the nucleus with the protons. And this has a neutral charge, 0, no charge. It's not plus, it's not minus, it is neutral, okay? So the positive proton, which is in the center, the neutral neutron, is also in the center. And then finally we have these outliers, and these are electrons, okay? And these are, however, not like the proton or neutron. These are not in the nucleus. These are not in the center, okay? So not in nucleus. Hopefully you guys can still see that. And we're getting a little low. It's okay. So electrons are not in the nucleus. They're not in the center. They're actually, here's the nucleus, they're whizzing around the nucleus super, super fast, almost at the speed of light. It's super, super quick. Okay, they're whizzing around the protons and the neutrons that are in the center. Okay, and these electrons have a -1 charge. Okay, so I don't really have a mnemonic, or is that a mnemonic? I don't have a way to, like, positive proton, neutron, negative electron. Yeah, pretty lackluster. I don't want to talk about it. So, just to recap, pause if you need to, write this in your notebook, whatever you want. The protons are in the center of the atom, in the nucleus, right? The nucleus. And these protons, they are positive proton, okay? They have a +1 charge. Next, we have the neutron. If you can remember these two together, it's kind of easy to remember the outlier, the loser electron, right? Me in high school. So the neutron is also in the nucleus. It's in the center of the atom, just like the proton, okay? They're all clumped together. And if you can remember, positive proton, we have neutral neutron. There's no charge, 0 charge, okay? Neutral neutron. Remember that. And then finally, I don't have a way to remember electron, but if you can remember, well, I know positive proton, neutral neutron. I know that there has to be a negative, right, in the universe. Positive, negative. You have the electrons, and these are not in the nucleus. These are whizzing around. You can think of an atom kind of like our solar system, okay? So the sun, which is at the center of our solar system, has the protons and neutrons, right? And then you can think of our planets kind of like the electrons. They're orbiting the sun. They're orbiting the nucleus, okay? So there's another way of thinking about it. And these electrons have a -1 charge, -1, negative electron, okay? Okay, so get all that bad writing and art out of the way. So now we know the three, these are subatomic particles, right? We know the three subatomic, meaning below or under the nucleus, or of the atom, sorry. Subatomic particles, okay? So the three components that equal the atom are the subatomic particles. So now we know that. Now, I'm going to get into this in another video, what atomic mass is, but I'll kind of touch on it right now just to give you all the properties of the subatomic particles. So, just like you know with anything, everything has mass, right? And a lot of people, maybe shouldn't get into this, but I think it's important. A lot of people equate mass with weight, right? And that is not true, because on Jupiter, which has a much higher gravity than Earth does, I weigh 300. On Earth, I'm a chiseled 170, okay? I'm like super buff on Earth, right? Don't want to talk about it, guys. Don't comment anything. It'd be so embarrassing if you did. Seriously, don't. I'd be blushing and stuff. I don't want to talk about it. It'd be super embarrassing. But on Jupiter, I weigh a lot more than I do here on Earth, and that's weight. So weight can actually change based on where you are in the universe. If I have a super heavy gravitational pull, then I will weigh more. But it doesn't matter if I'm in a black hole getting with the weight of 1 billion pounds, I still have the same mass as I do here on Earth. Mass is a measurement of matter, the amount of matter in something, right? So for example, if I weigh 500 pounds on the sun, I don't know what it is, but 500 pounds, that's because it's pulling me down more. But if you just looked at the stuff that composed of my body, I'm not gaining more mass. I just weigh more because I'm being pulled down harder. Does that make sense? So, didn't really need to go into that, but, you know, it's fun. It's cool science, right? So mass is the measurement of matter in any object. And everything around us, anything with atoms, with mass, or sorry, anything with mass, or, oh my gosh, anything with matter has mass. There we go. What I'm trying to say is even these subatomic particles, these super, super small particles that make up an atom, have mass, okay? So even though we can't necessarily see the individual atoms, if we took one out, it would have mass, right? So, let's get into this. So we know that we have a positive proton, and this has a +1 charge, okay? Now, how do you think we should measure this tiny, like I said, atoms are super, super small, and the subatomic particles are even smaller. A proton and a neutron and an electron are so, so small. What am I going to measure that in pounds? Pounds if you're a stupid American like myself. Kilograms? It's like saying, hey, you know, instead of saying I'm going to go run a mile, I'm going to go run 1,000,000 centimeters. if you say that, you should probably get bullied at school. Okay, that's just, I don't condone bullying, but come on. You don't say it like that because you would just say I'm going to run a mile, right? So we have created a unit of measurement, if you will, to properly weigh or measure the mass that these particles have. And those are called AMUs, or atomic mass units. You'll see AMU written all the time, because who wants to say all that? It's too much work, right? So atomic mass units are essentially another unit of measurement used to give a mass to these tiny subatomic particles, because they're just too tiny. You wouldn't use pounds, kilograms, ounces, grams, none of that, right? It's too big. The particles are too small, but that unit of measurement is too big. So we use atomic mass units, okay? So a positive proton with a +1 charge has an atomic mass unit of, drum roll, 1. It's super simple, just 1. You can say a proton has a mass of 1, okay? And 1 atomic mass unit, okay? Now, we'll keep that up there. Neutral neutrons, almost misspelled that, with a charge of 0, right? They're neutral neutrons, they don't have a charge, also have a mass of 1. Pretty simple, right? So we know that protons have a mass of 1, neutrons have a mass of 1, and then finally, I'm going to erase this because I'm running out of space. Electrons, this is where it gets a little weird. It's not tricky or anything once you understand it, but it's kind of weird. So we know that everything with mass has, here, let me just tell you and then I'll explain it. Electrons, negative electrons, this whiteboard is flimsy, with a -1 charge, have an atomic mass of 0. Now, before you go crazy, because I know how much you love science, don't lie. But Jake, you said, the host of Molecular Mindset, sponsored by Dr. Pepper, you said that everything in the universe, every bit of matter has mass, right? Yes. So then why is it 0? Well, because electrons, remember, electrons are whizzing out, orbiting the nucleus, right? The protons and neutrons in the middle. Electrons are orbiting super fast around. They're super, super small, super tiny, okay? And they do have a mass, but it's so small that in simple chemistry, unless you're some nerd loser PhD working on, I don't know, the fusion or the cure for, I don't know, that doesn't make any sense, but whatever. Unless you're working with electrons in a very, very small, you need to know the mass of them, we just call it 0, because they weigh so little. They have such a small mass that we just consider them 0, okay? So I want you to remember, electrons do have mass. They do have mass, because everything that makes up the universe, matter, has mass. But when you're just doing basic chemistry like this, it's negligible. So we call it 0, okay? So we have protons, neutrons, and electrons. Oh my gosh, my handwriting looks amazing. Protons have an atomic mass unit of 1. Neutrons have an atomic mass unit of 1. And electrons have an atomic mass unit of 0. Now, we know, though, they have mass. It's just so small, it's negligible. We just count it as 0, okay? So that will be the end of this video. I just want to get a quick introduction. I'll do a little practice quiz. Pause your video. Pause your video. I don't know why I'm saying it like that. So I want you right now to tell me a couple things. Here, I won't even write it. This is all you, dog. Don't mess this up, okay? Or I'm going to be super disappointed. You don't want to see me okay, that was so cringe, sorry. So, what are these subatomic particles? How many are there? What are they? What are their names? Okay. What is their corresponding charge? And then finally, well, no, one more. What is their corresponding charge? What is their atomic mass? And then a little extra credit question. Where is each subatomic particle found in an atom? Go ahead and pause the video. Okay, let's get into it. So, first, I'm going to probably go out of order, but that's okay. First, we have proton, and we have the neutron, and we have the electron. Okay, so right there we've answered 2 questions. There are 3 subatomic particles. Here are the names for each of the subatomic particles. We have the proton, neutron, and electron. Next, what is their corresponding charge? Well, we know the positive proton, which you should have said when you were doing the quiz. The positive proton has a +1 charge. The neutral neutron has a neutral charge, sorry for yelling, and the negative electron has a -1 charge. Okay? Now next, what is their atomic mass? Well, we know that the positive proton has an atomic mass unit of 1. We know that the neutron has an atomic mass unit of 1 as well. And then finally, the electron has an atomic mass unit of 0. But we know that there's still mass. It's just so small we don't count it when we're just doing simple stuff like this. Okay? Finally, bonus question. See if you get a cookie. And I'll send cookies out. Just they might come moldy, but I will send cookies out if you get these right. So leave it down in the comments, pro YouTuber. So finally, where are each of these subatomic particles found? Well, the proton is found in the center. Here, we'll write it just right under. Center. Another word for this is the nucleus. Okay, so the protons are found in the center, or nucleus. The neutrons are also found in the center, or the nucleus. And then finally, the electrons, if you want to sound really smart, are found orbiting the nucleus. Okay? Put it simply, they're just whizzing around the center, the nucleus, where the protons and neutrons are. They're whizzing around, flying super, super fast, almost at the speed of light. But we call that orbiting, right? Just like I said earlier, the planets orbit the sun. Electrons orbit the nucleus, the protons and neutrons. So hopefully that makes sense. Please let me know what I can do better. It's my first ever video. I love to teach chemistry. I love chemistry in general. I just love it. It's just super cool. I'm not trying to nerd out, but I love it. So please let me know if this video helped you at all. Please give suggestions on what I could help next down in the comments. And yeah, I hope this helped. So good luck for your test that you procrastinated studying for. Good luck. Take care, guys, and bye-bye.